We have finally reached the final question, that is question number 21. And if you recall, this question has been already solved in the question number 15. Let me just show you. This is the question, and we have solved the same questions, question number 10 to 16, in the question number 15 as well. So if you go back and search for that question, if you go through that, you will come across these as well. But, anyways, we'll do it over here now. But before we begin, I just want to stress that here it's in writing. So whatever methods you use for the part A, it might vary. Here, please make sure you do it in detail. Don't use the calculator method. There is a trick to solve this in calculator, but don't do that. We'll do in writing. And again, before we start, I'll just let you know about and the word or. If it's and in the number line, it must be within certain range, okay? If it's or, it will be two separate range. From here to here is a solution, and from here to here might be the solution. So this is the difference. We have done that in thorough in the question number 15. So what I would suggest is, if you're not gone through that part, please go with it, be thorough, and then watch this video. Now, and means it's always separated. So we have to separately solve both these inequalities. Here, minus 4a plus 13 is greater than or equal to 29, and the other inequality is 10 less than 6a minus 14. So this is the first step. Just write the given. Now, how do you solve it? The numbers at one side, variable, leave it over here for now. So I will leave minus 4a. This 13 goes to the other side, will be greater than or equal to 29 minus 13. Here, you can do one solving properly and then the other one. So I'll just solve this one. It is greater than or equal to, symbol remains the same. But here it's 29 minus 13. It's 19 minus 3. That's 16. And we have negative 4a. So what do you do now? When you have minus, see, this variable is negative. Now there is a rule that states to change the sign. You can change both the sign, but this variable changes. So what you do is, let's change the sign. This becomes plus 4a. This becomes minus 16, but the inequality changes. It flips. This is the rule which you must remember. You've done this before as well. You can change the sign of inequality, but the inequality flips. It became 4a less than or equal to negative 16. A must be less than or equal to, take 4 to the other side, it will be negative 16 by 4, negative 4. This is one inequality. What about the next over here? Let's solve this up. Here we have 10. Take this 14 to the other side, it will be 10 plus 14 less than 6a. It will be 24 less than 6a. And we have, what do we have over here? It's 6. 24 divided by 6 is 4 less than a. We will write it. Now we are not changing the symbol. Just a is greater than 4. We'll just write the same thing. A greater than 4. That's it. We have just rewritten this. Now here the inequality flipped because we changed the sign throughout. But here it's not the case. We just have written it, the variable first, the number next. A was greater than 4 or 4 is less than a. The same thing remains here. A is greater than 4 or 4 is less than a. Now if you look carefully, now if you draw the solution set, what is it? Is it possible? This is and. See, always it's and. For and, we must always have the solution set something like this. Now since it's inequality, let's have minus 4 somewhere over here. This is less than or equal to, so it's a point, and 4 is somewhere over here, it's a whole. It must be within this range. The solution must be like this, between this both. Is it the case over here? No, here what do we got? What have we got? A is greater than 4. That means this is all the solution, and less than. This is supposed to be like or. So this is wrong for and. We cannot have this. There is no solution for this case. There is no solution. Why? Because there is nothing overlapping. All this are the solution and all this is the solution. So there is no overlapping. So it's basically a null set. There is no solution. Let's just check the answer. The solution set is null. This, okay, mine looks a bit weird, but I'll tell you how to write that. It is 0 and dash, or basically we write 0 and like this line. Okay, this is how anyhow we can write it. Okay, it should be a 0 and null, or you can just put 0 and dash, that's easier. So that is the thing, and there is, just draw the number line. There is nothing you can graph because over here there is no solution to graph. Okay, this is the thing. And in and, please be careful. It must be within. Let's just look into one more problem over here. Just okay, this has a solution. See, this is how it is to be for and when it's and, right? It'll be always like this. Now here the same concept. We have done this before as well. Now you must solve this much first and then this middle term and this term. So I'll just change the color for that. Here it would be, second inequality would be this and this. You can see that's the thing. And first inequality, what I've marked in black, these are the inequalities. Solve them, you'll get the two answers. And now what is the answer? B is greater than 4. It's just greater. So you can see there is a hole over here and greater than 4, right side. And B is less than or equal to 5. Less than means point, and it's all within this. So all this is the solution. That's it. Now that's about and. Over here again, please do solve it the same way. If you get two answers which is coinciding in the sense it's between the range, that is the solution set. Whereas if it is or, you must have two solutions. This is the same method. There's nothing. It's just or. But remember, the solution set is like this. One is greater, one is lesser. Now these are or solutions. This or this is the solution. It's not and. And will be within, or will be separated. So this is it. Over here again we have another or, and this one we had seen it even in the question number 15. Look here, n is less than 3. So if we have a number line, that's a crooked line. Now this one, imagine this is minus 3. N as a whole, because it's less than, that's the answer. And then greater than, this is the answer, right? But what is happening? Here, all possible set are possible because from minus 3, greater than is true, less than is true. But since it is only greater than or less than, this number minus 3 is not included. Therefore, all are solution but except minus 3. But if it was less than or equal, greater than or equal, then it would be just all real numbers. All real numbers are the solution because even 3 is included. When it is only less than or greater than, like this, see over here, when it's only greater than, less than, the 3 number is not included, all the other numbers are included. That's what it is. And over here, it's again an and problem. We know and problem, it will be within a certain range. So you need to differentiate between and or. And if it's or problem, we will get like this at the ends. It goes up till infinity. So this is basically it. That's the end of the question number 21. So more details for this particular question is in the question number 15. So please go back over there, be thorough, and then move to this one. That's it. I hope these explanation videos have been helpful. All the Haikal topics have been explained, part 1 and part 2 separately. So please try to go through all of them. And I wish you all the best. I hope everyone gets great marks. And if you have found this useful, please do consider subscribing to my channel. That would mean so much to me. And also do share it with your friends or anyone you know might find it useful. All the Cycle 3, grade 9, 10, 11, 12 advanced, and also 10 elite explanation videos are available in my channel. All the best and take care, guys. Happy learning.